This is another problem for related rates. Suppose that a company manufactures calculators. The cost, price, demand, and profit equations are given by the cost function is C of Q is equal to 90,000 plus 330Q. The price demand function is Q is equal to 9,000 minus 30P. And the profit function formula is that P of Q is equal to R of Q minus C of Q, where the production output in 1 week is Q calculators. I would like us to find the revenue function. Well, the revenue function, R of Q, is equal to the quantity that you sell times the price. So it's Q times P. Where P, we have to take our price demand function and get P by itself. So we have P, if I solve that for P, I get P is equal to 300 minus 1 over 30 times Q. So just by taking the price demand function and solving for P. So R of Q is going to equal Q times the 300 minus 1 over 30Q, or 300Q minus 1 over 30Q squared. If production increases at a rate of 500 calculators per week, when production output is 1,500 calculators, find the rate of increase or decrease in cost. Well, cost, dQ dQ, sorry. Cost is dC, dQ is going to be the rate of change of cost. And we can see that that's going to be taking the derivative of dQ with respect to Q of the cost function, which was 9,000 plus 30Q. So that's going to equal $30 per calculator. But I didn't want to know that. I want to know what the rate of increase or decrease is in cost. So I actually want to know what it is per week. So I actually am looking to find dC dt. And dC dt using related rates is dC dQ times dQ dt. Use your units to help see what it is. We just found dC dQ to be $30 per calculator. We need to also multiply that by dQ dt, but we're told that the production increases at a rate of 500 calculators per week. So that is dQ dt. So we have 500 calculators, or I'm sorry, 500 calculators per week. Calculators will cancel, and you'll be able to see that you're going to get $15,000 per week. We also want to find the revenue. Again, we want to know the rate of change of revenue, so we do want to find out what dR dt is. Well, dR dt, same idea, is going to be dR dQ, because we can find out how R is affected by Q, times dQ dt. So dR dQ, we know how R is related. So you're just going to take the derivative of R of Q, and that will give you 300 minus 1 over 15th times Q. And that's going to be your dollars per calculator. And then you're going to multiply that by your 500 calculators per week. And then Q is equal to 1500. So we're going to go ahead and put 1500 in there for Q. So dRdt is going to equal 300 minus 1/15 times my 1500, because Q, we were told, or Q we could find by putting in our price into this equation. You come up with Q is, so Q is 1500. Oh, we were told originally that our output is 1500 calculators. That's how we got Q. So Q is equal to 1500. You're going to multiply that together, and then you're going to multiply that by your 500 calculators per week. And that's going to give you, your revenue is $100,000 per week. For profit, the easiest way to do this is, remember, profit is equal to revenue minus cost. And so you want to find dP/dt, which is just equal to dRdt minus dC/dt. And you know what those already are, so all we have to do is subtract them. So dP/dt is equal to dRdt, which was $100,000 per calculator, minus dC/dt, which was $15,000 per calculator. And so your profit is changing at a rate of $85,000 per week.